Still out? Not everybody here? Okay. He really doesn't like the class. Okay, so let's begin. So until now, what we did, we introduced the first form of inequality. This is one form of inequality suggested by Combe. If we multiply each dimension by a bistochastic matrix, a common one, that means we reduce the inequality, keeping the mean same for every dimension, we have increase in human development. Now let us talk about the indices that has been proposed and that satisfy this particular axiom. The first one, the first such index was proposed by Higgs in 1997, and Higgs was it came out in World Development, and Higgs was kind of motivated by the sane welfare standard. So what is sane welfare standard? In the first stage, Higgs suggested aggregate across person for each dimension, okay, by using sane welfare standard, where sane welfare standard is defined by S, which is mu1. What is mu1? Anyone? That means mu gamma for gamma equal to 1, and that is arithmetic mean. So take the average of each dimension across all population and then multiply it by 1 minus G. G stands for Gini coefficient. Okay? So what happens when means remain same and inequality increases? What happens to sane welfare standard? Sane welfare standard goes down. Okay? So you actually punish the distribution for being highly unequal. If inequality falls, then Gini falls, this entire term goes up. As a result, sane welfare standard goes up. So Higgs suggested at the first stage, for each dimension, you take the average and multiply by Gini. For life expectancy, it could be life expectancy across different regions. This is difficult to calculate across persons. And in the second stage, you have these 3-dimension specific indicators, sane welfare standards. Okay? Take simple average. So instead of taking simple average and then simple average, you calculate sane welfare standard for each dimension, each of the 3 dimensions, and then take simple average. What happens as a result? If you have reduction in inequality in any dimension, keeping the mean same, okay, you reward that country for reducing inequality. If you have a fall in inequality, sane welfare standard goes up, and then the overall inequality adjusted human development index goes up. Okay, if you had used a simple HDI or traditional HDI, there would have been no impact. Not again. We're getting power? Okay. Okay. So an example, so you have the same matrix as we had earlier. So the first stage, average across persons yield 0.5, 0.5, 0.5. So your mu1 is 0.5, 0.5, 0.5. A 3-dimensional vector. The Gini, if you calculate, you can calculate by hand. I did it. You can verify. It's 0.22, 0.22, and 0.22. Why they are same? Because they are literally same distributions. Okay? So the first stage achievement vector is 0.39, 0.39, 0.39. How did I get that? Average of what? I multiply, yeah. So the first stage achievement vector is mu times 1 minus Gini. So 0.5 times 1 minus 0.22. Okay, it's 0.78. Half of 0.78, it's 0.39. So the second stage average yields just 0.39 because they are the same. Now suppose we take we create another achievement vector x bar. How was it created? Now person 2 and person 3, their income has been equalized. So you have fallen inequality. What we had earlier was this one. Now if you take the average of these three, this 0.35, 0.35 and 0.6. So you have 0.35, 0.35 and 0.6. It's just average. Okay, so this distribution, so each dimension is now more equal, right? And now if I calculate the first stage average across persons yield 0.5, 0.5, 0.5. Look at Gini. The Gini has gone down. It was 0.22, 0.22 and 0.22. So the average is the same, but the Gini has gone down. So we are going to reward the dimensions. So the first stage achievement vector is 0.4, 0.4 and 0.42. If we take simple average, it's 0.41. So earlier it was 0.39, right? And now it is 0.41. So clearly you have an increase, you have rewarded. Although the mean remained the same, look at mean, they remain same. If you had simple HDI, you would have 0.5, 0.5, 0.5, average is 0.5. No change. But here, you had earlier 0.39, but now you have an increase of 0.41. Now, this is a problem with Gini index, that the Gini index is not subgroup consistent. That means if you have two groups and welfare of one group didn't change, but welfare of the other group increased, you could have a fall in overall welfare. And that could mislead you in terms of empirical application. So Higgs index satisfies these nice axioms for understanding all of it, including uniform majorization, but is not subgroup consistent, not path independent. Is this property too important to you? Do you think it's very important that order of aggregation doesn't matter? Well, we'll see it later then. Okay. Now, so Foster-Lopez-Galvez-Ekeli found that problem, that it is not subgroup consistent, and the second problem was Gini is so difficult to calculate. I mean, you need really a huge computational power. If you have, for example, 10 million observations and you are trying to calculate Gini, taking the distance of each one of them, it's going to take huge time, okay, and huge memory. So what they decided, let's make it a little easier. So first, aggregates across persons using mu alpha. So you have this distribution of income across all persons, distribution of education, and then you have distribution of health. Okay, so you first take a generalized mean. That means you discount for inequality. If you had taken simple mean, you had come up with a number. If you take generalized mean and there is inequality, you have lower value, right? You do it for every dimension. In the second stage, so you get three values for three dimensions, applying generalized mean. Then you again take another generalized mean across these three dimensions. That means you are punishing for the achievement in lower dimension at the aggregated level. So you double punish actually. You punish existing inequality for each dimension, then again you are punishing for lower achievement in any dimension. If some countries really have not been achieved a lot in terms of education, that country should be punished. Okay? So this one is path independent. Can you see why? it turns out that Forster-Lopez-Calvan-Zeckel index is also path independent. It does not matter which way you aggregate. You see why? So, suppose for simplicity, we have 2 dimensions and 2 persons, right? First, what you do, you are going to take generalized mean of that and then generalized mean of that. So what do you get? x1 to the power alpha, I'm sorry, it's y1 and y2, plus y1 to the power alpha whole to the power 1 over alpha, and then you get x2 to the power alpha plus y2 to the power alpha whole to the power 1 over alpha, sorry, divided by 2 is alpha. So x1 to the power alpha, y1 to the power alpha divided by 2 whole to the power 1 over alpha is x2 to the power alpha, y2 to the power alpha divided by 2 whole to the power 1 over alpha. Then in the second stage, what you are doing, to the power alpha plus to the power alpha again whole to the power 1 over alpha. Okay? And what is exactly happening? This alpha and this alpha, they cancels out. Oh sorry, this is divided by 2 again. So alpha alpha cancels out, this alpha cancels out, and you end up with x1 to the power alpha plus y1 to the power alpha plus x2 to the power alpha plus y2 to the power alpha divided by 4 entire to the power 1 over alpha. Everybody with me? That means now if you run the same exercise with these 2 and these 2, again this 2 alpha will cancel out, you will end up with this one. So it is nothing but, Forster-Lopez-Calvan-Zeckel index is nothing but taking, if you have this matrix of dimensional achievements, is nothing but raising everyone to the power alpha and divide it by total number of element, which is n times d, raise and again undo it by 1 over alpha. Okay? So again, it does not matter which way you aggregate, you are always going to have the same result. Is everybody with me? If you have any question, please raise your hand. Okay. So it's actually the same power. So how can you interpret the parameters here? When you are applying generalized mean here, okay, what Atkinson called epsilon, what was called the epsilon parameter for Atkinson index? Inequality aversion parameter. Exactly. So lower the alpha, more inequality averse you are. Okay? So when you do your aggregation across persons for each dimension, alpha is interpreted as inequality aversion parameter. When you apply alpha across dimensions, can anyone tell me what it indicates?
Equality between dimensions.
In economics, who are from economics? Who has seen C as utility function? Constant elasticity of substitution utility function. What is the interpretation of the parameter there? Substitution between dimension. Very good. And that relates to elasticity of substitution. Okay? So the substitution parameter and the inequality aversion parameter, they are the same here. And that is doing the trick, making it path independent. Should they be same? We will see later. May not be necessarily. Okay? We'll come back to it. Okay, so let's see the example. Use the same achievement matrix. You have first stage generalized mean across persons yield 0.4, 0.4, 0.4, but generalized mean of order alpha equal to -2. I forgot to put it here, but you can write it down. Alpha equal to -2. So it's order, or gamma equal to -2 rather. I define generalized mean by gamma. Okay, so it's of order -2. If you apply that, you get 0.4, 0.4, 0.4. And then second stage generalized mean of order -2 again yields the same. So first stage you apply generalized mean of order -2 across these three. So you apply generalized mean of order -2 here, you get 0.4. You apply again here, as they are same distributions, 0.3, 0.4 and 0.8, you get same value at the first stage. Okay, so there in the second stage there is actually no inequality. So whatever substitution parameter you use, we use -2, the same value, you get 0.4. So far so good. So the reverse order of aggregation would yield first stage, if you do this way, again with order -2, it is going to yield 0.46, 0.4, 0.36. Generalized mean here yield 0.46, generalized mean here 0.4, generalized mean here 0.36. Next stage you apply generalized mean on this vector and it is going to yield 0.4. So you won't have to even do these two stages. You just raise everything to the power -2 in this matrix, divide it by 9 and then again undo by 1 over alpha. You will get the same result. As they are path independent, you directly can calculate mu alpha from this matrix. You don't even have to go through two stages. So the order of aggregation does not matter. Again the example, we have same kind of inequality reduction transfer, you can say, where you have smooth the achievements of second and the third person, and then we have this result. So the second stage generalized mean order yield again 0.41. Okay, and you can see that WF of x is 0.4 as we had earlier, but WF of x bar is 0.41. That means an increase. Okay, so you are rewarding for reduction in inequality, although you have same dimensional means. So what was? Yeah, so they both are inequality sensitive.
So you would reward also if one person had more equal results between dimensions.
Then what are you saying? You are transferring income from someone to education? Yeah, it can take that into account too, because you saw. But I don't know how intuitively that would make sense. That would be a different kind of study. Yeah, that has been, some people have asked, but I have not done any work on, or I have not seen any where they talk about this. It is no more inequality anymore, isn't it? It's substitution between dimensions, and I don't know how to defend that exactly. So it's rather reducing inequality between dimensions. But what do you mean by that? You see, taking some away and giving to someone else. It's a good question. So what we saw until now is that we assume that we have distributions, okay, and then we can apply general mean or Gini coefficient on distributions, calculate them, and then calculate the inequality adjusted HDI. Problem in real life is that there are many data set that doesn't allow you to do that. For many data set and many variable, they are available at the aggregated level. For example, access to water. It's a dummy variable, 0 and 1. What you can calculate is that at the village level, whether you have the proportion of person having access. It's really difficult to calculate your personal score or score of a household, life expectancy, child mortality. Okay, so there are many other literacy rate. They are not available at the individual level. And if they are the only option available to us, what we should do? So there is an approach where people have suggested calculating group-based HDI. So individual or household level data are not always available motivation, and even they are available, they cannot be calculated for every variable. And generalized, and the other motivation they had was a weakness of generalized mean. That generalized mean could be difficult to understand by a lot of policymakers or many people working in the government. It could be difficult. And the fourth one was, sorry, I forgot to write down the fourth one. The fourth one is given that Foster, Lopez Calva, and Zekeli, they don't provide what alpha you should choose. So they leave that option for policymakers to choose alpha. Gets kind of living degree of freedom. I mean, you can choose your own, how inequality averse you want to be. Because if you just calculate Gini, you don't have any option to choose from. So it's a kind of normative criterion where you can set up your norm. But this study, they actually argue, no, this is actually not a good thing, because if you leave more choice sometime, might mislead you. Okay? Not good for you. So Hurstein, Clason, and Misselhorn proposed a group-based inequality index. I'm sorry, not human development index. So they first divided the population by income quintiles. So they prioritize income somehow here. Okay, so they divide the population by income quintiles. First, richest, second richest, third, then second most poor, and poorest. Okay? And then they calculate human development index for each quintile. So you have human development index for the lowest quintile, human development index for the second most quintile, and so you have 5 human development indices. And their index would be, so this is the table, and this would be their measure of inequality, how unequal HDI is. Okay? So they, yeah.
When they divide out the population in quintiles, do you do it in terms of income?
Yeah.
Is income not on a multidimensional?
No. It's in terms, so they prioritize income. You could do it in terms of education, but they did it in terms of income. Okay? So so this is the HDI of Q1 and Q5. Okay? So have you seen this kind of ratio earlier? What are they called? Maria Emma must have shown you. What are they called?
90-10 or something? No.
Yeah. And it has a name. Someone proposed it in 60s. Beginning in the name with K. Ku. Kuznets. Exactly. Kuznets ratio. So Kuznets ratio is proposes 80-10. This is 80-10, right? You have 5 quintiles, 20, 40, 60, 80, and 100. And this is just the ratio. Okay, so it is nothing but a Kuznets ratio, but over HDI instead of incomes. And you can see higher the value, more unequal that society would be. Guyana, it's probably 2, and then Burkina Faso 1.9, USA 1.2, but it suppresses a lot of inequality in the US. In US, it has a lot of inequality lying between, I mean, within each quintile, and it is ignored. So US is faring much better here. But if you calculate the Gini coefficient of US was more than 4.4. It was pretty high. It was higher than even in India or Sri Lanka. It was 0.41 or 0.42. It's pretty high. But in terms of human development, it seems they're performing very well. I doubt. Okay, so this is another way of looking at inequality, but doing it separately, not constructing an index incorporating inequality inside. Okay, so they just calculated simple HDI that is not sensitive to inequality, and then compared across quintiles. Okay, so it's not inequality embedded inside the Human Development Index. Okay, but in a useful way. So pros, easily applicable, easily understandable. Cons, the first thing, the problem with Kuznets ratio, it ignores the within quintile inequality. Okay, so it is not exactly sensitive to the entire distribution, just looking at 5 values. It may not satisfy UM. UM was uniform majorization. So if uniform majorization takes place within a one group, so within the second quantile, you don't see any effect because the HDI of that group remains unchanged. The third one, I think, it defends the dimensions while constructing HDI. So it implicitly assumes that the dimensions that were chosen to construct HDI were correct. And I don't know. How good is that?
How do they calculate the life expectancy?
For each quintile, so they take the quintile, so they have the selection of these households, okay, and then they calculate within that section the death rate or whatsoever.
But it's not life expectancy. It's the same one as
Yeah, they claim to be the same one, but yeah, you're always allowed to, welcome to study the paper. I cannot exactly remember, but it's life expectancy. In general, people would suggest using child mortality, but as far as I recall, they used, you can check it over the internet if it is available. Just verify it. But as far as I recall, it's life expectancy. So it defends the dimensions while constructing the HDI. That could be a shortcoming because life expectancy might not be a good indicator for measuring health. And recently more and more household data are available. So why not applying at the household level? Because that is the best way you can capture inequality throughout the entire distribution instead of smoothing at some places. I mean, I agree that health variable, for example, it's not possible to get at the household level. It's really difficult, rather. I don't say impossible. But rest of the variables, they're available. Why not select a different dimension or different variable, different indicator and calculate? Okay, so up to now, questions. So we talked about two types of methods. One method incorporating inequality inside the Human Development Index, and another one calculate Human Development Index, but then verify across group how unequal they are. Okay? So before we move on to, but remember we said that there could be two types of inequality, multidimensional inequality, and we talked about only one. Okay? Now I'm going to introduce the second one. But before that, if you have any question until now. Should I move on? Let's go. Okay. So here I try to introduce the other form of inequality. So suppose we choose dimensions so that individual level information for each of them is available. So we assume here that we have individual level information available for each dimension. Somehow we have been able to do that. So reconsider the achievement matrix. Now, suppose human development is calculated by applying either Higgs index or Foster-Lopez-Calvan-Zeckel index. Okay? So I ask you the question again. It's just read it as an assistance. It may not have to be dollar. It may not have to be money. Okay? It's just an assistance. So where should the assistance be spent? It's now sensitive to inequality. Okay? So if you give it to, pardon me? Person 3, and where? Person 3 dimension 1, and why not here? Well, but what? Yeah. Correlated? Yeah, we will come back to that later, but I am applying this any of these two. So suppose you are a policymaker, you are applying any of these two methods. Where would you assist? Which person and which dimension would you assist? So suppose you don't know about correlation, suppose you don't care about. You are applying these two only. Okay, where would you spend?
Person 3 dimension 1.
Person 3 dimension 1, if you calculate Higgs, then where would you have maximum fall in inequality? Here or okay, that makes sense. It makes sense. Person 3. So would it actually make any difference where you spend here, here, or here? Because if you see Foster, Lopez-Calvazekeli, they are taking general mean of this entire matrix. Okay, so whether you spend it here, here, or here, they don't identify. If you do Higgs, you have same distribution. So wherever you spend it, here, here, or here, you will have same Gini coefficient, same change in Gini coefficient. So actually it does not matter. So if you are a policymaker and you are using any of these two indices, you are actually indifferent spending. It doesn't matter to you. Come on. Why put some effort to identify the proper person? Just spend it on the dimensions. You see? But ethically, what do you think? Pardon me? Person 3? Everybody agrees? Person 3? Okay. It depends. Why?
Alpha 2.
It depends.
It depends on our the dimension, and if we actually consider one of the dimensions essential or more important than the other.
And Gaston has talked about it, and Mariama has talked about it. Dimensions could be related as substitutes or complements. Okay? So this would be the answer that you already gave. So where should the assistance be made from an ethical point of view? You said it depends. Suppose dimensions are highly substitute. That means if you have more in one dimension, you can compensate it with the other dimension. In that sense, ethically, yes?
If it's the case of person 3.
Exactly. Okay? So these two methods actually fail to take that into account. So if you are a policymaker, you are applying any of the yeah. Okay, so when dimensions are substitute, what does that intuitively mean? Say loud so that everybody can hear. A little bit more. So if they substitute, then if you increase in one dimension, then the other dimensions you can substitute, you can compensate the other dimension. Now this person has lower in other dimensions too. So this person cannot actually compensate his lower achievement by the other dimensions. So in that sense, his is less well off compared to person 2. So ethically, if the dimensions are substitute, which they are in general, okay, because if you have, I can argue, but you can argue in the other way too. It would be nice to have a debate. So if someone has, say, low income but has good health, that person can actually work more to earn more income, compensate his less well off in the income dimension. Or if you are handicapped, that you are less well off in terms of health, but you have a lot of income, you can buy a wheelchair for yourself. You can compensate your health in that sense. Okay, so I can argue they are more of a substitute. Any argument there could be complement?
I mean, the ethical point of view might take into account new information when you're considering the class of saying that you're it's not necessarily that you will automatically maximize the welfare either at an aggregate level or the worst of all.
Yeah.
From an ethical point of view, using
Okay, so
it's not I don't think it's completely straightforward.
yeah. It's just an exemplary purpose. Exactly. It's an exemplary purpose. But so any argument for dimensions to be complementary? Any example? Whether dimensions could be complements to each other?
Like health and education,
They're not substitute?
health and education, I don't really find that.
Yeah, that's a. Can you give me an example why do you think it's more complement?
This, I think if you're not healthy, also if you're more educated, you cannot compensate for your health.
But if you are more educated, then you actually, can take better care of your health, better nutrition or whatever. In that sense,
But you have to prevent most of the diseases, not prevented just because you are more educated.
no, I agree. But some of the diseases you can.
They're not perfect substitutes.
No, I didn't say they're perfect substitute. Never. I didn't say they're perfect substitute. You can say that if you have good health, then you can probably work hard and when you are a kid, right? And you can get more education. So it depends on in the age group, it depends on at what level you are. So what I try to tell you that it's really difficult to judge or from a policymaker's point of view, it is difficult to say whether dimensions are substitute or complement. But in general, people argue they could be more of a substitute. They could be complement at certain levels too. But how do you incorporate that? Our welfare index, human development index, they're not so developed yet. And work needs to be done. Any of you can do it in future. Okay, yeah. If you believe that, then that prevents you at the outset in creating a multidimensional index. If you believe each dimensions are intrinsically valuable, then never construct a multidimensional index because each dimension is valuable on its own. So whenever you are trying to create a multidimensional index, you are implicitly assuming there are some trade-off between dimensions. Okay, so suppose the overall achievement of the nth individual is calculated by the simple additive form. Okay, just suppose that they are just averaged. Then if you assist, so this is the initial achievement vector. If you assist the dimension 1 of person 3, okay, then the vector is going to be this, look like this. Similarly, if you spend or assist person 1 in this dimension and person 2 in this dimension, you are going to have this kind of distributions. Now which one, suppose the second stage aggregation is sensitive to inequality. Okay, it's just for a simple example purpose. Real life would be more difficult. Okay, so which distribution you think more ethical after? So it is your initial distribution?
No.
Spend the dollar of dimension 1 of person 3. Okay, so you think that is more ethical distribution if that is our first stage aggregation. Okay, if you have seen utility function, if this is the first stage aggregation, and suppose instead of stating overall achievement, I use the term utility, and utility is obtained by taking average of 3 dimensions, what kind of utility function it would be? For what kind of utility function you just take simple average of 3 commodities? and it is called perfect substitute, right? If you have a utility function which is equal to the average of these two commodities or linear combination of these two commodities, then there the indifference curve is a straight line, it's perfect substitute. So here we kind of treat it as perfect substitute. So they substitute more of it, that's why you defended this dimension. Okay, these indices can also not differentiate the following one. If you look at these two matrices, you have seen this kind of transformations before? Have you seen this kind of transformation? So what is happening here? Okay, now in this dimension, compare second and third person. Is it true that second person is always more or more in every dimension? What about this one? No. So you made a transfer so that now one person has more of all. This transfer is called an association increasing transfer or correlation increasing transfer. Okay? If you take the correlation between these dimensions and this pair of dimensions, you have more correlation here than this one. Okay? So here, person 2 has always more in every dimension. Here, no. So ethically, this distribution could be more unequal. If dimensions is treated as substitute. Okay? Questions? You could disagree. Is everybody okay with this? So, if you have increasing correlation, the distribution you can very well say is more unequal. And although they have same dimension specific means, okay, the mean didn't change. Look, and each distribution didn't change. So if you have three decentralized planner, health, education, and another one, could be third one, from their point of view, is there any change in distribution if they are looking at individually? So health ministry is just looking at health. Education ministry is just looking at education. Okay? There is no change from their point of view. Is the combination that changed. So if they don't work together, they cannot identify the problem. That is another motivation of constructing multidimensional index rather than looking each dimensions individually. Sometimes, yeah, you can argue that dimensions, each dimensions, they are important on their own. Okay? And you shouldn't combine them. But here is an ethical explanation why you should construct, why at least you should look at multidimensional index. I'm not saying you don't look at the dimension specific indicators. You need to do. Please do. But at the same time, look at the multidimensional index as well. How it is going on. Or what is going inside. Okay. So the second form of inequality across persons is association sensitive inequality. So here is the association sensitive axiom, strictly decreasing and increasing association, again assuming substitutability. Theoretically, if you consider complementarity or if you choose your dimensions strongly so that they are complement to each other, there could be another axiom which could be strictly increasing and increasing association. So when association increases, your welfare increases. But here we assume substitutability, and that's why it's strictly decreasing in increasing association. So if dimension specific means they're unaltered, or distributions rather, not mean, it's much more strong. If dimension specific distributions are unaltered, but the correlation between them is increased, then you are going to have more unequal distribution. So here H prime is obtained from H by a sequence of association increasing transfer. That was one association increasing transfer. But distribution could be obtained from another distribution by a sequence of association increasing transfers. So here is a proposition: a human development index that aggregates across persons first and then across dimensions is not sensitive to association among dimensions. Look, in this for the purpose of this lecture, we are considering only those two classes where aggregation takes place in two stages. You could just combine everything together and construct an index. I'm not considering that situation, because mostly in empirical literature or also in theory, people construct in general in two stages, whether it is a poverty index, multidimensional poverty index, or a multidimensional welfare index, or an inequality index. Okay, so first you aggregate by person and dimension, then dimension, or first dimensions by persons. So here what we are saying, a human development index that aggregates across persons first and then across dimensions is not sensitive to association among dimensions. I showed you that association among dimensions, consideration of that is important for policy purpose. Okay, and an human development index that aggregates, like what has been done by Higgs or traditional human development index or Foster-Lopez-Calva and Zekeli index, they aggregate first across persons, then across dimensions, is not sensitive to association. There is a result by Datta, Patnaik and Zhu, it's probably 2003 paper. They also proved that the aggregation should take place first across individuals to construct an overall well-being index for each individual, then apply the second stage aggregation. The corollary: no path-independent human development index is sensitive to association. So I asked you how important path-independent property was. But do you agree that path-independent property is so important? Okay, path-independent property gives you a nice feature that you can aggregate in whichever direction, it doesn't matter. At the same time, it ignores association between dimensions. Okay, to be association sensitive, so therefore if assuming that the aggregation takes place in two stages, so it could be a possible human development index. It is an extension of Foster-Lopez-Calva and Zekeli index, where you aggregate first for each individual across dimensions using mu beta. Okay, the parameter beta is the substitution parameter between dimension. The second stage you apply, but not the same parameter beta as was done by Foster-Lopez-Calva and Zekeli. Remember, for Foster-Lopez-Calva Zekeli, the inequality aversion parameter and the substitution parameter, they were the same, and that was leading path independence. So path independence seemed to be not a very good property if you are interested in policy implication. Okay, so take two different values, and it can be shown, although I'm not going to prove it here, that it satisfies these properties along with subgroup consistency, uniform majorization, and SDIA, which is strictly decreasing under increasing association. Okay, if you set value of alpha to be less than beta. Okay, I'm not going to prove the results of this class. You can read the paper. But this is the result. So if you set alpha less than beta, they are going to satisfy these properties. This is an extension of the Foster-Lopez-Calva and Zekeli index. Okay, so we ask the question again, and suppose alpha equal to -2 and beta equal to 0.1. Give the assistance on dimension 1 of person 3, then your human development index is going to be 0.465. Okay, if you give that assistance to person 2 of dimension 2, then your HDI is going to be 4, 5, 6. If you give this, if you assist person 1 in dimension 3, then you have least increase in your HDI. Okay? So, if a policymaker, if you could convince a policymaker to apply this index, then the policymaker should have an incentive to assist the third person who is ethically important, because that will fetch maximum increase in your human development compared to these two. Okay. So here is an application, since application of this method on the same data set that Foster, Lopez Calva and Zekeli used on Mexico, on various Mexican states. So you have ranking, there are probably 30 states. It is difficult to fit in the slide. So I presented only 7 of them. And then what I did, I selected a state at random, which was the state of Tabasco. And what I did, I rearranged all the dimensions so that the correlation increases, keeping the distribution same. So if each decentralized policymaker, they are looking at the distribution separately, they don't see any change, but there was increase in correlation inside. They were all perfectly positively associated. Okay? And as you can see, it was 254 earlier, it actually became 244, and it fell by 1 rank. So if you keep the distribution unchanged for 3 dimensions, but you increase the association among them, treating dimensions as substitute, then you should punish for existing inequality. And I applied the same method on all, but the value fell and the rank also deteriorated. So the Tabasco with high correlation. This is Tabasco from the dataset, and this is Tabasco where dimensions are unchanged, but only they are shuffled so that they have high correlation. Okay. So here is the summary what we did today. So traditional human development indices are not sensitive. I used indices because there could be other possible measures as well. It could be floating around. Okay, you might not know. So if you just, if they're simple additive, you just take average of dimensions and then take a simple average, they are not sensitive to inequality at all. We introduced 2 forms of inequality. The first form is distribution sensitive inequality. Measures incorporating this inequality internally, okay, inbuilt, was Higgs index and Foster, Lopez Calva and Zekeli index. Measures incorporating inequality externally, that means they didn't incorporate inside the human development index, was Hertzchen, Klassen and Messelhorn. And then we introduced the second form of inequality, where we showed that dimensional interactions could be important for policy implications. And then we showed that aggregation should take place across dimensions first and then across persons. Now there is a trade-off. You cannot say that the last index is uniformly or unambiguously better than the other indices. You lose something. Sometimes you might be interested in finding what is the contribution of a particular dimension on overall human development. When you apply this association sensitive index, you lose that power. Okay? So if you are interested to see how dimensional contributions are important, I mean there could be some sophisticated statistical methods I am still not aware of. Okay, but intuitively you lose that power. You cannot find out. For Higgs index, for example, you first calculate each dimension specific sane welfare standard, and then you take simple average. and that allows you to say the contribution of a particular dimension to overall human development index. But when you do that aggregation first across persons, across dimensions for each person, and then aggregate across all persons, you lose that power. Okay, so it comes at the cost of something. And here we treated in generally the dimensions symmetrically. We didn't take weighted generalized mean. We just take simple generalized mean. It's equivalent to giving equal weight to all dimensions. But trust me, this study can be extended to weighted generalized mean. It is possible to give different weight to different dimensions, but still the results will hold. Okay? Questions before I move on to the next lecture? Are you sleepy after lunch? Yeah. Me too. Okay, so what I thought that I have 1 hour of lecture left, so what I thought I would introduce multidimensional inequality briefly. I am not going to go in more detail. I will just discuss the multidimensional properties or axioms. Most of them you have already seen in Mariama's and Gaston's discussion. So I will just go through them briefly, and then I will just show you various multidimensional inequality indices that are floating around, but that has not been applied a lot. Okay? So I will just give you a brief overview, but I am not going to go in a lot of detail. This is not possible in 1 hour. Okay? And then what we will do, you have an assignment which I have already given you. So we will go through it in the last hour. There is this data problem as well. I think you are expert enough to solve it now. And if required, we will come back. What happened? Do you have a question? Oh, I thought you have a question. It's okay. So there will be an exercise in the last hour from 4:30 to 5:30. That's the time I think. And then if we don't finish it, 1 hour might not be sufficient. We will try to finish it tomorrow morning from 9 to 10. Okay? So I will go through the multidimensional inequality lecture right now. Any other questions?
Robustness we are going to do tomorrow, right?
Tomorrow. The last session on robustness. Okay, so let's go to multidimensional inequality. Why it's important? What is the motivation? Well, study of inequality is probably important on its own, and I think previous lectures have given you enough motivation to the study of inequality already. The basic needs approach, capability approach leads our analysis to multiple dimensions from single dimension, and there why inequality is just important over there. I don't think I need to motivate it separately. So what I will do, I will talk about the basic framework, which is almost identical to the framework that Maria Emma has talked already, or I have given when I was talking about the Human Development Index. I will talk about related axioms. Again, they are going to be very similar. Introduce various inequality indices, and try to discuss a little bit about their pros and cons, where they can be applied. Multidimensional inequality indices has not been yet applied a lot. So again, n persons and d dimensions as we had earlier. Xnd is the achievement of the nth person, dth dimension. Xnd is greater than 0 because most of the inequality measures they based on generalized mean. However, for inequality measures, Xnd could be negative if you are talking about absolute inequality indices. Okay, So for relative inequality indices, generally it is better if we assume xn greater than 0, but when we are talking about absolute inequality indices, it could be negative. Again, similarly, vector for the nth person is denoted by this, and the overall vector for in the dth dimension is the same framework. I tried to keep it same so that it's easier to understand. So x star is the achievement vector of the nth person, and similarly for xd. Now, similarly you could have these basic axioms. The first one is normalization. What was normalization in welfare context? What was the axiom of normalization in the welfare context? Can anyone remember? When we were talking about HDI, we also had an axiom called normalization. What was that? Yeah. That is inequality context, but what was it in the context of Human Development Index?
The formula of the log of GDP and to compare.
I want to see who is awake. Everybody had same achievement, okay, in every dimension. Then the welfare index was equal to that particular achievement. That was normalization in the welfare human development context. Thank you. Okay, so if everybody had same achievement, okay, if xn star, or if each individual has same achievement vector, it is capitalized because this is a vector. Okay, if individual has same achievement vector in suppose say in 3 dimensions, then there should be no inequality. Okay, anonymity. Personal identity does not matter. Now, can anyone tell me the mathematical definition? Maria Emma definitely had introduced it. Permutation. So if you pre-multiply by a permutation matrix, then inequality should remain same. So what happens if you post-multiply by a permutation matrix? What does that mean? Yes? If you pre-multiply by a permutation matrix, you are saying you are permuting. So what happens if you post-multiply by a permutation matrix? An intuition? Pardon me? Loud. I cannot hear. Please.
She's afraid to say it.
Show it, you are not. Okay, so it is going to be that you are permuting the dimensions. So suppose all dimensions were symmetric and had equally weighted. Okay, then if you post multiply, you are just switching the dimensional space, and it shouldn't matter. It's a very strong assumption. Not exactly perfect. A perfect substitute, you could also have perfect substitute with unequal weights. You see, because weights are trade-off, right? Now, if it is saying that if you permute the dimensions but don't change the weight, then you should, if you have unequal weight, then the index is not going to be the same. So, if you post multiply and if you want the dimensions to be anonymous or symmetric, that's a very strong assumption. That means you are defending equal weights. Okay? So here what you are doing, anonymity, the mathematical definition, as we already mentioned. So it's permutation matrix. If you pre-multiply, then it's going to be the same. Inequality is not going to change. Scale invariance, if all elements in X is changed by an equal proportional amount, the inequality does not change. Yeah?
Sorry, can you repeat the limit one? Like, if you change the dimension,
No. It is, anonymity is changing persons, so personal identity doesn't matter. What I said, could there be another axiom called dimensional anonymity? That means if you post multiply by a permutation matrix, then inequality remains unchanged. But that would be kind of assuming each dimension is treated symmetrically, which is really strong assumption. You see? So we are not going to assume that. I just asked you. So scale invariance, if all elements in X is changed by an equal proportional amount, then inequality doesn't change, or rather shouldn't change. Any related axiom you found in Human Development Index? Any related axiom that we introduced when we were talking about Human Development Index? Proportional change, linear homogeneity, homogeneous, so linear homogeneity. So linear homogeneity, what it did, when you changed, when you increased, everybody's achieving the same proportion. Exactly, welfare increased in the same proportion. Here, if you increase everybody's achievement in the same proportion, then inequality shouldn't change. Okay. Now there is another axiom in the inequality context. If all elements in X is increased by an additional amount, then inequality does not change. So it is related to two different kind of inequalities. One is relative, one is absolute. Which one is relative and which one is absolute, you think? It's relative and this is absolute. Okay, so this is the definition. If you increase each achievement by a certain amount, inequality doesn't change. The next one is Popri. You already had it in lambda is negative. Yeah, it could be. It could be. I mean, I try to restrict it because I assume extend greater than 0. So for any lambda, if you take less than 0, that extend could become negative. So to keep that assumption intact, I assume that, but you were right, it could be. You see, I assume extend greater than 0. So if I want to keep extend greater than 0 and take a lambda, then it is possible that for some lambda less than 0, extend could become less than 0. Okay, as I made that assumption, I kept it greater than 0. But if you remove that assumption from there, that extend could be anything, lambda could be less than 0 too. Makes sense? Thank you. You were right. So population replication invariance is the same axiom that you learned in terms of HDI. So if we replicate the population several times, inequality shouldn't change. Decomposability. So overall inequality can be expressed as a general function of the subgroup means, population sizes, and inequality values. So if you have two different groups, overall inequality should be divided or should be a function of subgroup means, mean of each group, population sizes of the two groups, and inequality values. Inequality of one group and inequality of the other group. You have seen this decomposition, Mariama has probably shown you. For Gini, you can have kind of decomposition where you find a residual. For a generalized mean, you don't have any residual. Okay? And for general entropy, there are particular type of decompositions. Okay? So they are all function of subgroup means, subgroup inequalities, and the size of the group. So it's just a mathematical definition. I mean, it looks so ugly, an ugly animal, but it is not. Okay? Intuitively, it's clear. And then again, you have subgroup consistency. We have already talked about it. Finally, continuity. So it's CONT. There's an extra N. Probably I was sleeping. Okay. So uniform majorization, again, if you have one distribution obtained from another distribution by multiplying by a bistochastic matrix, that means you are reducing the inequality of each dimension, okay, then inequality should fall. So for an example is, look at them. Okay, so which one should have higher inequality? left one. Okay. Now this is the definition of correlation increasing transfer. Mariam has already probably given you. This looks uglier, isn't it? So the interpretation, you saw the example, can you remember? That you gave someone, you made the transformation so that someone has higher achievement in all dimensions. This is what it is doing. So it's considering any two person in an n double prime. Okay. So that you have yn in the new matrix, person n1 has maximum of all, both of them. Okay, where this term refers to the maximum, I'm sorry, this is minimum. So one person has minimum of all of them. Okay, the other person has maximum between all of them. Okay, I will give you the example again. I will repeat the example for your understanding. Then it is called correlation increasing transfer. Mariama called it basic rearrangement. Okay, because that was the particular term used by Boland and Prostien. But later in Sui changed the term to correlation increasing transfer. So again, the old example. So here the second person have more of these two vectors, right? This person has maximum of these two vectors, maximum of these two, maximum of these two, maximum of these two, and the other person has all the minimum. So here one correlation increasing transfer took place. It could be the other person, it could be the other way around. You could have another matrix where this person has all more, this person has all less. That would be correlation increasing transfer too. Okay? And this is the definition of correlation increasing majorization. Okay? It is related to this strictly decreasing and increasing association property that we introduced earlier. So correlation increases majorization is higher correlation between attributes for given marginal distribution should lead to a more interpersonal inequality. That is this. So you have higher inequality here than here. Again, it's implicitly assuming dimensions are substitute or complement? Substitute. So for indices with two-stage aggregation approach, if the aggregation takes place first across persons and then across dimensions, indices do not satisfy CID. Is the same conclusion that we had from the construction of welfare index. So whether you construct a welfare index and welfare index, whether you construct an inequality index, whether you construct a poverty index, one thing is for sure, if you want them to be correlation sensitive, you cannot aggregate first across persons then across dimensions. You have to go to the other way around. You have to first aggregate for each person and then aggregate across all persons. Okay. So here you go, the definition of absolute and relative inequality index. So absolute inequality index must satisfy translation invariance axiom beside others, and a relative inequality index must satisfy scale invariance axiom by definition. Okay, so there are these indices, inequality indices, that are currently floating around. Okay, not all of them has been applied. The first one was proposed by Masumi, as it seems, 1986. Then it came Sui, then Bourguignon, then Gasdos and Wemark, and finally Descartes-Lugo, which is the most recent one. It has not been published yet, this paper. So what are the ideas? Bourguignon index is very similar to the final welfare index that we constructed. Okay? So first aggregates across dimensions by the aggregator function. So this is the aggregator function. So it's the general mean to the power alpha. Have any one of you seen Bourguignon and Chakraborty poverty index? It's the same first stage aggregation form. You are taking general mean and then just to the power alpha, just to make it correlation sensitive. And the second stage, is just simple average of all of them. So the first stage, you come up with all n individual level index, and then just take the simple mean. And then define W bar equal to U bar. What is U bar? U bar is so that every individual in every dimension receives the mean. So every individual has the mean health, mean income, mean education. You see? So every individual has the average. So it's a matrix containing all the individuals, same equal number of individuals, but each having the mean achievement, mean score. That means, what about the inequality? There's no inequality. And exactly, and it is assumed that welfare is maximized. With same mean, as inequality falls, you see, welfare goes up. The same concept here. No inequality, welfare is maximized. And then the inequality index can be constructed as 1 minus W over W bar. It's like Dalton index. The same concept. Okay? So, as inequality falls, this welfare rises. Okay? When it is perfectly equal, this is equal to this one. As a result, inequality is 0. Because W bar divided by W bar equal to 1, 1 minus 1 equal to 0. So inequality is 0. Now here beta is the substitution parameter and alpha is the inequality aversion parameter. IB satisfies, okay, they're in short form, I'm sorry, I forgot to change that one. So this is normalization, this is actually anonymity, scale invariance, decomposability, and this one replication invariance. Yeah, and both forms of inequality sensitivity. Okay, is inequality axioms. Okay, and inequality increases with correlation when you have this restriction. Is a similar restriction that we had with the final human development index. It can be shown that this welfare index is actually monotonic transformation of one another. Okay, so what they didn't do here, they didn't undo it by a 1 over alpha. You see the entire thing, they just had to undo it by a 1 over alpha. They just didn't do it. Okay, and as a result it has a problem, I will tell you. But before that, let me show you how to calculate. It's easy. We assume beta equal to -2 and alpha equal to 0.5, and we give equal weight to every dimension. So the first stage, you calculate U1, U2 and U3 for 3 persons. Okay, so this one and this one. So the calculation from the first row gives you 0.68, from the second row 0.63, and the last row it's 0.60. In the second stage, you are going to take a simple average. You ended up with 0.64. Then you need to calculate H. Okay, what is H? H is the average of all dimensions. Okay, if you take average of the first dimension, what do you get? 0.5. Similarly, 0.5, 0.5. So it is as if each person has this achievement, so that there is perfect equality. So each person has the same vector 0.5, 0.5, 0.5. Okay, you calculate U bar and then W bar. So the inequality index is nothing but 1 minus 0.64 divided by 0.71 equal to this.
How far you are
from the maximum welfare that we achieve with maximum equality. So a given distribution, perfect equality gives you the maximum welfare. Okay, so it tells you how far you are from that identical situation. Okay, there is a problem though. The role of inequality aversion parameter is not clear. So inequality aversion, what should be the interpretation of inequality aversion parameter? what do you think? I mean, what should be the interpretation when someone tells you that it is an inequality aversion parameter? What should be the interpretation? What do you understand by it? Pardon me? That means sensitive to inequality, that it should have a monotonic relationship. If it falls, then probably inequality should be more inequality averse or less inequality averse, any one of them. It shouldn't have that you keep on reducing the value of inequality aversion parameter. Okay? You become inequality aversion for a time and then you start becoming non-inequality averse. That shouldn't be a good inequality aversion parameter. This is the problem happens with this index. Okay, so it has little problem because it didn't undo like Atkinson. Yes. So the inequality aversion parameter, you generally assume that what will happen with the inequality aversion parameter, as you keep on changing the parameter in one direction, either inequality aversion should rise or inequality aversion should fall continuously. It shouldn't happen that you change inequality aversion parameter, your inequality aversion, true inequality aversion falls, and then after a certain point it starts rising. It's a non-monotonic relationship. Okay, this happens with this particular class of indices. You have an example in exercise where if you calculate you will see it is happening. Okay, so it is in your exercise. So main problem, the intuitive problem is that in the first stage what they did, they took the general mean beta and then raised it to the power alpha. In the second stage they just took simple mean but never undid it by 1 over alpha. That is the main problem. Okay, so when alpha changes, both this one, the denominator and numerator, both of them are changing. They shouldn't change. The denominator for Atkinson index, the denominator where you have same inequality, there is no inequality. If there is no inequality, an inequality aversion parameter shouldn't have an impact. But unfortunately it changes this denominator. As a result, you ended up with a non-monotonic relationship. Yes?
I have a question about some slides ago, the translation invariant.
Relation?
The translation invariant
Yeah.
axiom.
Uh-huh.
Why would we want that to hold for an inequality index? Does it mean that if you give the rich has $100, you give $1 to him, is it the same as giving $1 to a poor person who has only $1?
That is what the main critic against absolute index. That is the same question that James Foster asks every time. How do you defend absolute inequality index? That's why he prefers to use relative inequality index. Okay, but sometimes there are some people, there will always be some people who doesn't like relative inequality index, but it is saying that okay, you having some person having $1,000 and the other having probably $1, and you increase both of their income by 100 times, still someone has $100 and someone ends up with 1 million probably. How do you defend that? You see? So yeah, in real life probably it will be a kind of convex combination of these both true properties. See? Okay, any question on this index? It will be in your exercise to solve. Okay, the next one I would like to talk about is Masumi index. It has been widely criticized by social choice theorists and people in this area. Esfandiya Masumi is a very good econometrician and he runs the Journal of Econometric Reviews. The first stage is a generalized mean, simple, but the second stage is a generalized entropy. Somehow he characterized the first stage general mean. Look, you will often find people using this generalized mean or so-called CES utility function at the first stage, but they all need to characterize it. They all need to defend why they are using it, because it has very limited properties. Okay, it treats every dimensions with equal substitution parameter. It doesn't allow for two dimensions to be substitutes and two other dimensions to be complement at the same time. Okay, it's very limited. But they defended it with an information theoretic approach, which I'm not very versed with. Okay, you can really go to and read the 1986 paper. Also, he has this paper appeared in Handbook of Economic Inequality, 1999. Okay, where Bourguignon index has. Bourguignon index actually was a reply to Masumi's index. Okay, because Bourguignon didn't like Masumi's index at all, so he constructed another one as a in the commentary section. So, frankly speaking, no one in the field of economic inequality has been able to provide an intuitive interpretation of generalized entropy. Okay, I don't have any intuition, no idea how it works. It has some terrible properties. You know, when alpha changes, you could have a non-monotonic relationship as well. So it's not really clear. There is no intuition. General mean has some intuition, you see. But I'm sorry, if you ask me what is going on there, I don't know. No idea. So what he did, this S bar was equal to the overall, in general, what people would like to do probably, instead of dividing it by S bar, which is the overall welfare, or see, S bar is the overall welfare, because UN is the well-being of each person, S bar is the average welfare. So some people argue that instead of dividing or using this S bar, if he had used the average value as was done by Bourguignon, it probably would have made sense. The main problem is that it satisfies probably a lot of properties, but not sure what restrictions on parameters satisfies different transfer principle. At some part, it is sensitive to, it probably reduces inequality. For some other parts, it is sensitive to increasing inequality. So it is not clear. So it is not well-behaved property, well-behaved inequality index. Okay.
Are there any application of this?
Masumi himself applied in his paper on in that paper on probably, I forgot which data it was, but he himself applied inequality of well-being or something like that. But apart from that, if you read Lugo 2005, Lugo talks about all these approaches, but I cannot exactly remember if Lugo applied on Argentinian data. But I cannot exactly remember if Lugo applied this index on that data. I remember that Lugo applied on Bourguignon index, and Bourguignon index on that data, but cannot exactly recall. Because that paper is actually a comparison between Masumi index, Bourguignon index, and SUI index. Okay? And at the end, probably Lugo preferred Bourguignon index. It was so easily understandable. And for Masumi index, how the parameters behaved was not clear at all, no restrictions. Okay, then SUI index in 95 and 1999. I'm not going to talk about the 1999 index because it was a characterization of generalized entropy as well. In 1995, he came up with this particular index. They are nothing but basically generalized mean. If you see, by the way, beforehand I should mention that the parametric interpretation of SUI index, impossible. I don't know. In general, I mean, for example, Bourguignon had this parametric interpretation. One is substitution parameter, one was inequality aversion parameter, but SUI's parametric interpretations, they're also not clear. I mean, I told you, can you remember that there could be three ways you can aggregate. Either, two stages, first across dimensions persons, first across person then dimension, and there is a third one, you just aggregate together. There's no stage. You just aggregate at the same time, everything. So this is, although same is two stage, but it's not exactly clear, the interpretation. I don't know. Maybe someone else can give you a very good idea or interpretation. So it looks like it's also a kind of generalized mean. You see? But I am not going to go in a lot of detail. I'm also running out of time. Okay. So we also developed another in 1999 on generalized entropy. I'm not going to go to that. Unlike Masumi, these indices had parametric specifications to satisfy transfer. But the problem, Sui parameters are not interpretable. It's not difficult to interpret. But yeah, he has restrictions. If you go to the paper, you can see what kind of restriction they have so that they satisfy different kind of properties. Okay? But I cannot interpret it. I don't know if anyone already has that. Then there exist few indices that extend the concept of Gini index in multidimensional context. Okay? The one paper was by Gasdos and Waymark. John Waymark is actually my committee member. So I shouldn't criticize probably too harshly. Index. So Gasdos index, what they did, at the first stage, they created a Gini social evaluation function, which is the Gini index, but it's a more general form. He also had another parameter in it. Okay, it's actually, I forgot the actual functional form. So Gini social evaluation function, which is the generalized Gini index, and he applied that index in the first stage across all persons. So for each dimension, he ended up with one generalized Gini index. Okay, and the next stage, the inequality index was a generalized mean of those Gini indices. I was working with Professor Foster one day, and it turned out that Hicks index, HDI, is actually a subclass of this index. Because can you remember Hicks? First stage, mu times 1 minus g, and second stage, the simple average. It is also doing similar thing. If you just play a little bit with it, you will find that this inequality index can be actually incorporated. Hicks index can be incorporated into this index. Although this is inequality index, they are related. Okay? Yeah, definitely. This is more general. That was also only one mean, average, and then a Gini, simple Gini. It has generalized mean and then generalized Gini inside. So this is more generalized. Hicks index can be mentioned as a particular form of index which falling in this class. It can be generated from Gasdos and Waymark index. Limitation again. Yeah. Yeah. Exactly. So first for each dimension, exactly. You calculate the Gini, generalized Gini, exactly. And then in the next stage, it's same as Hicks, right? Hicks also did mean times 1 minus g for every dimension, and then so it can be shown that they're actually related. The limitation, as you can see, it is first aggregating across persons and then across dimensions. The order of aggregation are to be not strictly sensitive to correlation among dimension. That has been pointed out recently by Descamps and Lugo. Okay? And they just reverse the order of aggregation. Definitely they had to go through lots of mathematics to prove their results, but the end product was they just switched the order. So the first stage was across dimensions for each person, exactly using a general mean, and then calculated Gini, social evaluation function. Okay, and that's their inequality index. Okay, so here is a summary that was pretty quick. So we introduced axioms, the basic framework, discussed various multidimensional inequalities, and pros and cons. Keep in mind, whether it is an inequality index, poverty index again, or a human development index. So you have two choices. One, you can ignore correlation within dimension, and it might be good sometime because if you are interested in these dimensional contributions, okay, then avoiding correlation might be a good idea, because then it becomes really difficult. It can only with some sophisticated econometric techniques you can find out the dimensional contributions. Otherwise it's really difficult, not intuitive. But if you think your policy implementation or policy recommendation is more important, then definitely, incorporating correlation into dimensions is very important. I mean, we had already discussion with correlation several times. Principal component analysis, what you do in HDI, should you select weight with principal component analysis? Well, principal component analysis is telling you how the dimensions are related at the aggregated level. But what about the disaggregated level? What about at the country level? If you are making international comparison, you apply principal component analysis in Mexico's dataset, principal component analysis in US dataset, India dataset, you have very different weights. And that doesn't allow you to make international comparisons. Okay, so it's debatable whether we should use that or where exactly should we use that, how should the trade-off go, how often should we use principal component analysis, where we should rely more on normative criterion, and how important is correlation, how related are the dimensions. These are the work needs to be done, has not been done yet. Okay, so we are at the very primitive stage. So we are talking about correlation, and we also talked about only one type of correlation increasing transfer. There could be different types of correlation increasing transfers. We don't know yet, or even if we know, we have not incorporated yet, because this is the area where social choice theories mostly work on. Okay, and ending up with as this particular functional form that is usable in practice, it's highly unlikely. They could satisfy lots of different properties, different axioms which are criticized. For example, monotonicity axiom, as I told you, monotonicity axiom can be criticized. On what ground? Monotonicity axiom is assuming that when achievement is increasing, for one person or any person keeping others same, welfare should go up. So you are implicitly assuming no achievement, increasing achievement, is harmful to the society. Right? So what happens? The achievement of Joker in Batman goes up. It could be harmful to the society. See? So these axioms can be criticized. Every axiom can be criticized, but they need to be defended in proper way as well. So what we try to do here, we try to make some compromise. We made a simple framework. Definitely we ignored a lot of aspects. For example, substitutability. We didn't consider the situation where two dimensions are substitute, other dimensions are complement to each other. There exist some functional forms or utility functions in the literature that has been worked in 1960s and 70s, and you will find probably there are different utility functions that tries to do that. But again, they are so difficult to incorporate in this multidimensional context. Taking this substitutability and then taking inequality across dimensions, it's a really difficult issue. So what all of these multidimensional form you saw, they have pros and cons, and they try to incorporate certain aspects. But it is really difficult to say which index is the ultimate index. It depends on your purpose. Gauss-Dose and Waymark, for example, if you are interested in absolute inequality, then Gauss-Dose and Waymark in their class proposed an absolute inequality index. Okay? So if you are interested in absolute inequality, Gauss-Dose and Waymark could be a possible option, not others. Okay, so if you have any question, please go ahead and ask. Otherwise, we will take a break. It's a little early though. We can come back a little early and begin our exercise. Or if you would like to see your exercise first before you go to break, just have a look. No? Break first? Okay. So please, coffee is here. Please go ahead and have coffee. Okay? Have fun.